All right, we're on problem 9 of the final exam practice. We have a recursive sequence being defined for us, and we want to find the first 4 terms of this recursive sequence and prove the general formula for the nth term. So we're given that the first term is equal to 1 and that the n plus first term is equal to 2 times the nth term. So the next term is equal to 2 times the previous term for every next term. So first, we'd like to find terms 1 through 4. Term 1 is already given to us, so it's equal to 1, of course, so that's pretty easy. We want the second term, and we know that the second term, so this is essentially using this formula for n is equal to 1. We know that n equals, or a sub 1 plus 1, so a sub 2, which is what we're looking at, the second term, is equal to 2 times a sub 1. So using our recursive formula for n equals 1, and we know what a1 is, it's equal to 1. So we have 2 times 1, which is of course equal to 2. So this is our second term. So we go to the third term, which is of course just equal to 2 times the second term. So using our recursive formula for n equals 2 in this case, and we just found a2. a2 is equal to 2. So this is 2 times 2. This is equal to 4. And then a4, our fourth term, is just equal to 2 times our third term, which we found is just equal to 4, so this is equal to 8. All right, so those are the first 4 terms, 1, 2, 4, 8. And now we want to try and guess a general formula and then also prove it. And we'll prove it by induction. So let's just write down our terms. They're going to be powers of 2, and we just need to figure out the appropriate power of 2 that they're going to be. Of course, they're going to be powers of 2 because it starts off as a power of 2. 1 is 2 to the power 0, and then every next term is given to us by multiplying the previous term by 2. So either way, a1 is equal to 1. 1 is just 2 to the power 0, as I just said. a2, our second term, we have is equal to 2. 2 is, of course, 2 to the power 1. So it's starting to look like it's 2 to the power n minus 1 that we're looking for. a3 is equal to 4. This is 2 to the power 2, right? 2 is, of course, 3 minus 1. 1 is, of course, 2 minus 1. 0 is, of course, 1 minus 1. So we're going to guess the formula an is equal to 2 to the power n minus 1. This is for all n greater than or equal to 1. And so now we want to prove this formula. So either way, we're going to use induction to prove it. So we want to look at our base step. We've already proved our base step. I mean, we've already shown that our base step holds. So either way, our base step is that the first term is equal to, so plugging in n equals 1 in this formula, so 2 to the power 1 minus 1, so this is 2 to the power 0, this is equal to 1, and of course we already knew this, but either way, our base step is true, and then we want to assume our induction hypothesis. So assume that we have that this formula holds up to some value of n. So let's assume that we have a, so this holds up to some value k. So let's say an equals 2 to the power n minus 1, as long as n is less than or equal to k. And so this is our induction hypothesis. And in particular, what we're assuming here is that when n is equal to k, this formula holds, right? So this also is going to imply, so when n is equal to k, so we're looking at the kth term, this is equal to 2 to the power k minus 1, okay? And then we're assuming that it's true for all values of n less than k, of course, but either way, then we want to prove from our induction hypothesis that this is going to hold for the k plus first term as well. So if we know it holds for the first through the kth term, then we want to show that it holds for the k plus first term, right? So if we know it holds for the first few terms, then we can show it holds for the next. So either way, that this is equal to 2 to the power k in this case, because 2 to the power k is just 2 to the power k plus 1 minus 1. Okay, so how are we going to do this? Well, we know the connection between a sub k plus 1 and a sub k, right, which we know the general formula holds for at least up to a sub k. And so we know this by the recursive formula. So either way, we know that a sub k plus 1, when we use k in the recursive formula, we're going to get that this is equal to 2 times a k. We know that a sub k is equal to 2 to the power k minus 1, right? And so, of course, this gives us, we just add a 1 to the power of k minus 1, so we have k minus 1 plus 1, and this is, of course, equal to 2 to the k. So the formula that we were trying to prove holds, of course, and follows from our induction hypothesis. And so by induction, we proved that this formula holds for all values of n, right? So we know that a sub n is equal to 2 to the power n minus 1 for all values of n now. All right, and that finishes up problem 9 for us.